In this episode of Finn-Ugric Machining, we are going to fix an issue with my BS0 dividing head. That's not brown and sharp, but it's a knock-off, a Chinese knock-off from that. Let's assess the problem and let's then fix it. Okay, here is the dividing head in question. And first let's take some things away from this. Indirect indexing first. This is, I have here a basket with all indirect indexing components. And this is really something. It's just a flimsy tin. Oh man. Okay. And then this one looks like it's brass, but actually it's cast zinc. Okay. And then, I have replaced most of these fasteners so that I can use the same tool for this. This used to be so that you needed 3 different tools to get these plates away. And that's the story of this dividing head. Please don't drop these into the floor. And then the plate away. And that's about the dividing head, indirect indexing. Why I wanted to remove this, and now we need a different tool. Maybe that one. This is because I want to disengage the worm. I don't want it to... This is like very difficult sometimes. Okay, that's loose. It's now also loose. And then you can just rotate it there. And now it should be disengaged. Okay, so you can rotate this now freely. Why I did this is because I'm going to extract the chuck from this. And in the backside, and now, let me put this away. Now this chuck, this system, I have a drawbar here. And this one, okay, it's like that. So we have here in the back, let me show you when it comes out. It's like this. It's actually a very strange nut in the backside here. And then I should be able, if I engage the brake really tightly, which way is loose? This way. You shouldn't tighten it. So now you can. This one has. I think this is something like Myford nose, I believe. I don't know what this is called, but as you can see, there is a drawbar, and this one you can thread in. Maybe let's not do it this. So that's the chuck. So now we start to have access to all these components. And that one I put also aside. And now comes small components. And for those I need this. And we have 3 little hex cap screws there. What was the size? It's not this, it's something different. Let's try that first. Too big. Next. No, that was the previous. Okay. These are easy enough to get away from here. That's loose now. Okay, last. So then this comes off. And this is just, as you can see, attached with 3 screws. And then we have the 24 direct indexing holes there. Okay. And then we have that one, and that one is different. We need to take this away as well. And that's mildly said funny looking thing. But it is. There it is. Okay. Let the screw be there. And then we have, in order to get this away, we have, I think it was really small, this one. We have here something. It's the next. These are really small, really tiny. Oh yeah, okay. So you will soon see what comes out from here. And this, I believe, is not the original design at all of Brown & Sharpe. This should be something else, I believe. Not a group screw like this, because this is the pinion now. It locks this, and if you look, it goes right in the middle of this. It shouldn't. I think the original design was such that when you had this screw, it went like over here, so it locked it that way in place. And this was, I think, it was like rounded, so that when you put it there, you couldn't get it out from there. So now this is one component I already took out. This pin from there, and this pin is something that when this disc is there, it will go by the pinion. Here is a rack. You can push it from some into the holes here like that. It pushes it into the hole, and yeah, that's the way how this works. But now the problem here is that the teeth here do not mesh. It slips. Now if I put this into here, it goes into that. Oh man! Need to be careful. Oh man! Let's try with these. These have a wider, these were needle sharp. Hopefully this fits in. Yeah, it does. So I can get it out from there. Oh man. So it drops in. So it comes inside here from the side, and then like that. And then you can push it with this one. And it's really sloppy. At the critical point it is like really sloppy. And this also has all sorts of, yeah, okay, anyway. I would estimate that the gear teeth are about 1 millimeter too low. And if I measure it from here, so there is a flat. This is a 10 millimeter pin originally. So, and it is about 10 millimeters. Yeah, it's a little bit. There is a little bit of a taper here, and it's not straight. And well, but anyway, the thickness, if you can see, well, let me zoom you in a little bit. Okay, there you are. Now, when I measure this, there is a flat, as you can see on the top here. So this flat, well, it's 10 millimeters, and this flat, if you measure from the bottom to the flat top, it is 9.25 millimeters. So they have taken it flat on the top, 0.75 millimeters taken away from the top. And now, as it happens, module 1 cut depth is 2.25 millimeters. So, and now when I measure the bottoms of these teeth, so the same way, they are at 7 millimeters. So the originally, or the intention was that it should be like module 1 gear, but the division, the pitch of these is not module 1. So it's something else. It's really something else. So, well, but what I will do, I will, yes, because now it looks like we are at least 1 millimeter wrong here. If I don't now push it all the way in, so I can, yeah. So I can tell by rotating this. It rotates like that. And it rotates so much that I can tell something like 15 degrees. So I can tell that it's about 1 millimeter at least. The bottom, the gear teeth don't bottom. So I can raise that about 1 millimeter, maybe a little bit less. Maybe 0.75 millimeters or maybe 0.5 millimeters. So I make a shallower cut for this gear rack, but I keep the, let's see now, that dimension here shouldn't go, and it doesn't go, I know it doesn't, it almost goes there. Almost. So this is probably in the correct plane, but the teeth are not. So what I now will do, I will go to my lathe and remake this piece. Now I will present you, let me zoom one more time. Hopefully this shows out so you can see. This is a picture about this. If somebody is going to reproduce this, here are the dimensions, and you can see there is a small taper at the end. That's important, really, and those holes are tapered. So that are the dimensions. It sure helps if you push the record button of your camera. Well, at this point I just chucked a 12 millimeter piece of cold rolled steel rod into my lathe, and then I made a good surface on that one so that it's accurate to measure. After that I measured it and noticed that there is 0.07 of a millimeter taper. And so the next step, which you hopefully now will see, is that I'm adjusting the tailstock using an alternative method for doing this. So I'm measuring it from the back side of the workpiece. This is to double the deviation. If I would measure it from the tool side, it would not. I would see nothing, no deviation there. And from the back side, I will see double the taper. So now, when I move it to the start point here, then I can reset the dial here. I will put it on 0 here, like that, and then I go against our stop, like that. So I can see that we have 0.7 millimeters here. 7 hundredths of a millimeter deviation. So I need to halve that. The nice thing about this measurement is that this is relative. This is, I don't need to know where this workpiece is pivoting. When you just simply adjust the tailstock measuring how much it moves, you are relying on the fact that it will, the point where it is pivoting. But I have no idea. It might be in the bearing of the lathe, it might be the tip of the chuck, it might be somewhere there in between. Okay. So I halve that. So I not lose the tailstock, but I will move it now to 3.5. And you will soon see that it's not actually 3.5 is there. And now when I move back, it's no more in the 0 here, as you can see. So then I need to re-zero this and see that we have the 3.5 hundredths of a millimeter deviation here. Well, it went bigger. So that was absolutely the wrong direction. Man, the other direction, please. So I need to have this deviation like 3.5 hundredths. And now it's 0.1. A little bit more. And the directions here are really, it's very easy to mix up. And where is this? Okay. A little bit more, let's see what happens here. Let's zero it here. Okay. And this seems to be illogical, but it's not actually when you do this. Okay. I should keep this as my 0. Okay, now it's totally gone. And this is actually bad. Now the taper is the other way around. So I need to put it back a little bit. Like that. Let's start as a 0 from here. And this is really delicate actually. It's not easy to do, but the thing is that, so 3.5, it's very near at the moment. It's actually 4. So if I move it really slightly now, that was maybe too much. This is now 0. And this here is now 5. Oh man. Let's try that one. 0 is here. Then go here. Now it is. So let's tighten this. Loosen the screw that that will deviate the tailstock. I will not let it be in tension, that one. So I loosen it when I'm finished, and then I recheck that we have the deviation of the 3.5 hundredths here now. Yeah, quite exactly. And this was tight, yeah. So there you are. The nice thing about this is that when you do this, you get it done in one go. You don't need to do this multiple times. When you do it like this, it will be straight after, and we will see whether it is or not very soon. Let's do a test turn here. I already aligned this compound with the end point here and etc. So now I just touch it because we have lost all that those setups. Actually, we didn't do it. Oh yeah. So let's take 0.25 millimeters. Oh, no. And this is always, I don't know why this happens to me. Tighten the tool. Okay. Now, let's measure that one. First, this end here. I try to arrange the camera in a way that you can see this as well. So, this is now 11.53. And this is 11.54. Well, 1/100th of a millimeter deviation in that distance. It was earlier quite a lot more. So, yeah, okay. There we go. Now the dimension, the nominal was 10 millimeters. But then I put our 10.02 millimeter pin into the hole where this goes, and it's a little bit loose. I would say like 3/100th of a millimeter loose. So I would make this something like 10.04. That would be, yeah. So let's take now 0.25 millimeter cuts from here. We are not in a hurry, so. Well, it's still a little bit rough, I would say. Not the one I'm after. 10.06 and this is probably 7 or 8 even. It's 10.08. Okay, I leave it now to that. And next step I will take some emery paper and I will... Okay, so let's measure this one more time so that we know what we need to... our target was 10.04. And at this side we are at 10.06. And this one is 10.08. Well, we have 300. It's quite a lot to take away with a, but well, not that much with a 5. So let's see now. I will. So because this side is bigger, I will take more from this side. Did it do anything? Glass. At least the surface became a lot better. Well, this is a very fine file, and well, well, maybe I need to clean it up first because it's really hairy. Okay. So now this was 8 and now it's 7. So 100 away from that. In the middle we are at 6, a little bit over 6, and here we are at the taper is now gone. So I can now do it evenly, even wipes. And I need to take away 200ths of a millimeter. Well, that's not too bad. Oh yeah. Well, now turning the end a little bit smaller. It would be 6.25 millimeters in diameter in this time. So, well, I have set up the stops, etc. It will stop quite exactly at 11 millimeters here. Hopefully. And I'm using now 1,800 revolutions. So it's really fast. Because the diameter is so small, it needs to be fast. There it is. Like that. Okay. So it should be now 6.25. It should be. But you never know. You never know, but this time it's, well, it's quite exactly. I'm adjusting the taper here. So in the distance of 5 millimeters, it should be 0.25 millimeters. So in the distance of 40 millimeters, it should be 2 millimeters exactly. So let's see. Now I have set this up quite coarsely, so let's see how much do we have here in 40 millimeters. That was 1 millimeter, and that was 4 millimeters travel, and we still are missing something here. So let's adjust this just a little bit more. Like that. That should be the correct value, but since it seems to be less, let's put it like this now. Roll it back to start where we start this. 4 millimeter, and of course this is now following the hypotenuse of our measurement. So it well, it's not exactly 40 millimeters here now. So let's put this into 0 and try again. 1 millimeter. We are there now. Here I make a rookie mistake. The dimensions, the taper, I did measure from diameters. Here I'm measuring the radius. Well, this means that the taper will become too steep. Luckily, later on, I wake up just in time. Well, I'll accept this one. This is good enough. So now, turning the taper at the end of this stick. I have glued this end, and then this faint line here, that one, is 5 millimeter mark. So the taper should reach to that point. And I'm using this boring bar because other tools I was not able to reach that one. So, and I'm using quite high speed here and feeding totally manual here. So let's first touch this one. Okay. Hopefully we didn't, no we did not. Okay, now I take 500 of a millimeter more. Then 500 of a millimeter more. Five more. Five more. Oh, wait a minute. Is this too steep? Yes, it is. Oh, it's too steep. Man! What shall it do for us? Oh well. We are at the halfway through now. There is still time to correct this one. Man! Start with that. Okay. Now let's take 500 more. Well, 500 more. But we should be there now. Well, actually we didn't spoil it. I catch the error in time. Yeah. Well, now we have the taper there. I did some beautification for this thing, and this is the side where it punches into this disc. And let's see now how deep it goes. Like that. Leaves exactly what I need. It's the 5 millimeters it should. Yeah. Okay. Milling of 0.75 millimeters from top of that. And you see the black lines. This is not really exact science how much I do this. It just needs to be enough. And when I make these black lines disappear, then that's enough. That's about it. Cutting the gear rack for this one. And this is module 1 cutter. This is module 1 cutter number 8. Means that it's intended for gear racks. And when I look into the original, it has even wider gap there under than this one. So if I match this with the teeth of the pinion, so it matches quite well. But the division, the pitch of these is nowhere near module 1. So therefore, well, I have there a table where I can check these. But since this is rather flimsy, I will take the cuts, several cuts for each teeth, maybe 0.5 millimeter, so that, well, nevertheless there might be some chatter. So let's just start this one. Yet another rookie mistake. Misplacing these teeth by 1 millimeter. Well, I should have stayed in bed. Perse. So these two are now, this is now ready. This is the new one and this is the old one, and as you can see it's quite a bit longer. And well, the gear rack, I made one mistake here. There is one teeth that is lower than the others because I mistakenly cut 1 millimeter aside. Man. And furthermore, now this fits quite perfectly there. It's a little bit tight, but so it should be. Let's put some grease into there. Ow. So I have here some grease which I should put there now. So I have done quite a lot of deburring with this one, and it's really, well, there you are. Oh, well. Okay, and now this is the thing, and of course I already tested this and it meshes really well. Yeah. And it's a little bit like tight, in the tight side, but let's see now, it should be about there, I believe. Maybe one step more. Yeah, okay. And it works really great. So the teeth in this one are 1 millimeter higher than in this one. And it's still there is a little bit of play here. Not that much. So from there you can guess how much this was on the edge of, it was slipping actually. So this is now, well, it's now into the bin. So yeah, let's put this together. So, and now I should Wow, it's there. Oh yeah, that's it. Fixed. Fixed und fertig. Yeah, aus die Maus. Ready to go. Whatever. Well, in the next episode of Finno-Ugric Machining, we are going to make 6 precision pins and put them into the cycloidic drive base. I'm still wondering whether I should make them a shrink fit or glue them into place. Well, gluing is easy. Shrink fit is better because in that way they are going to be straight. But we will see in the next episode of Finno-Ugric Machining what I have decided. Till then, bye!